Okay, so this lesson is over mean absolute deviation. This is actually my third try at recording this, and I'm tired. So I'm going to use the notes I've already written and kind of talk over them. There are 3 steps to doing the mean absolute deviation. They're right here. It's average, then difference, then average. First, you know what an average is. It's how we get your grades in the grade book. We add all your grades together, and then we divide by how many there are. So if you add all of these numbers together, you get a sum of 674, and then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So you divide the sum by 10, you get 67.4. That is the mean of the original data. All right? Then you take the difference of all the data points from the mean. So look what I did here. I took my first data point, 60 minus 67.4. You actually get a negative number, but if it's negative, you just drop it and you make it positive. Okay? 65 minus 67.4, you actually get negative 2.4, but we don't want any negatives. You just drop it and make it positive. 66 minus 67.4 is negative 1.4. I dropped the negative, made it positive. Okay, 67 minus 67.4, that's a difference of 0.4. Again, another 67, it's a difference of 0.4. 68 is a difference of 0.6. There's 3 of those. If you do 70 minus 67.4, you get 2.6. And you do 75 minus 67.4, you get 7.6. These are all of my differences. So the third step is you take all of these differences, everything I have circled in pink, you add them together, you add these all together, you get 24. Then you divide by 10 to get a MAD of 2.4. There's 3 steps. Add, divide, get the average, then subtract from each data point, and then average your subtraction values. You have a calculator to do all of that, so no whining. It's not that bad, okay? This is called your MAD, your mean absolute deviation. What it tells me is, if I have a MAD that is large, it tells me that my data is spread far apart. If my MAD is smaller, it tells me that the data is more consistent and there's not a lot of variation between the data points. So that's kind of what numbers 1 and 2 are talking about. If you have 2 sets of data that have a mean of 56, but the first set of data has a MAD of 2 and the second has a MAD of 1, that tells me that the second set of data is more consistent. There's not as much variation. The data points are closer together in set 2 than they are in set 1. Here, the 2 data sets have means of 40 and 50, but both have a MAD of 0.5. So in this data set, the numbers are smaller, right? And in this, but they're close together. They have a very small MAD. Here, the numbers are bigger, but they're still very, very close together. So that's kind of how you interpret a mean absolute deviation. All right, on the second page, they're showing you here, they're setting it up for you. This is your original data. So you add them together, 15 plus 11 plus 12 plus 10 plus 12. You can use a calculator. You get 60. And 60 divided by 5 is 12. So that is step 1. You add and divide all of your original data. Okay? Step 2 is you take all of the differences. I subtracted 15 minus 12, I got 3. 11 minus 12 is actually negative 1, but I made it positive. 12 is 0 steps away from 12, 10 is 2 steps away from 12, and 12 is 0 steps away from 12. So that's step 2, where you find all of your differences. Step 3, you take all of these differences and you average them. 3 plus 1 plus 0 plus 2 plus 0 is 6. Divide by 5, you get a MAD of 1.2. So step 1, step 2, step 3. Number 4, same thing. I'm adding up all of my data points. 1.5 plus 1.4 plus 1.7 plus 1.6 plus 1.8 equals 8. Divide by 5 data points, you get 1.6. Then you take this and you subtract it from every single data point. 1.5 is 0.1 unit away from 0.6. 1.4 is 0.2 away. 1.7 is 0.1 away. 1.6 is 0 away, and 1.8 is 0.2 away. Add them all together. 0.1 plus 0.2 plus 0.1 plus 0 plus 0.2 is 0.6. Divided by 5, you get a MAD of 0.12. That's it. 3 steps. The steps can be kind of tedious, but you have a calculator. Don't be lazy. That's it.